Hello, this is Dr. Henry again. Welcome to part two of using the using the periodic table to write electron configurations. Part two is the follow-up to the best-selling part one. So let's let's look at writing the electron configuration for europium, and europium is down here. All right, it's got an atomic number of 63. So let's try to write it up here, see if we have room. So we start once again, so this is 1s. So let's write down 1s2 because we know europium's not there. And that's all there is in this first period. So here's 2s. So 2s2, and then where we jump across this gap, this starts 2p. So we get to 2p6, we still haven't made it to europium. So here's 3s. So 3s2. Basically, we could think we mark these out as we do them. So here we go. And we're just reading this. So over here, we go through, we get to the end, we get to 3p6. We still haven't made it to europium. So here's 4s2. And then remember, D starts one behind. So here's 3d10. And then it's important to remember on the other side it starts back. This is 4p1. So we get to 4p6. After 4p6 we have 5s2. And then this is, once again, after 5s comes 4d, so we get all the way to the end to cadmium here. We still haven't made it to europium. So we write down 4d10. And then 5p6. And then we have here 6s2. And this is where it gets a little strange. So this is 5d1. So after 5d1, what happens is, instead of going on to 5d2, it starts filling in 4f1. So it goes 5d1, 4f1, 2, 3, 4, 5, 6. So 4f6. All right? So all of this would fill up to 4f14, and then you would start from the end here. You would go back and start filling in hafnium here. So this would be like hafnium would be 6s2, 5d2, 4f6. All right. So that gets a little complicated, and so I probably won't ask you to do ones like that. So let's look at a simpler example than europium. But that kind of gives you the idea of how this is done. So this next example, let's do iodine, which is right here. So atomic number 53. So let's do iodine. So it's down here. Once again, we start up here. So we go 1s2. There's nothing else here. 2s2. You go all the way at the end here. 2p6. Now you probably can't draw lines through your boxes because I can do this because I can, doing this on the computer, I can erase it, but you're just kind of thinking 2p6. Right here, what is this? That's 3s, so 3s2. Skip across, go through the little D forest here, you get to 3p, right? 3p6. Skip down here, 4s2. All the way to the end of the D block, 3d10. Get the krypton, 4p6, 5s2. Go through once again, get the cadmium, 4d10. And then here we get to finally where iodine is, so we need to count. So we got 5p1, 5p2, 3, 4, 5p5. Or actually, you don't even need to know to count, because if you look here, you know that this ends in 5p5. So it should end in 5p5. If it doesn't end in 5p5, then you did something wrong. So hopefully you find this pretty simple. Let's look at one more example though. Alright, oh my goodness, what have I done to the periodic table? So if you look at this, I've taken off all the marks. So you get this, something like this, and what you might want to do is you might want to just number the periods here. So 1, 2, 3, 4, 5, 6, 7, right? And then let's say you have some quiz on this, and you might want to go ahead and just put in 3, 4, 5, 6 here so that you can remember. So let's say you had to do iron. Well, we got to remember there's this block here, and think of it as a block, right? Because these two groups are taller than this. Remember, what is this? This was the S block. So you could number it S1 and S2 if you wanted to, or maybe just remembering that's the S block is good enough. Here in the middle, we have the P block, and then over, oops, oh my goodness. That's not right. That's not the P block. What is that? Sorry. I'm getting my letters mixed up. We got the D block here. So this is the D block, and this is the P block. So you may need to write that down. You may need to just think that in your head. All right? Now, we're going to go back to a totally clear periodic table and give this a shot. All right, so let's do this for iron. So we go, here's 1s1, 1s2. We still haven't made it to iron. So here is 2s1, 2s2. We go across. Here's 2p1. Get to the end to neon. That's 2p6. And it might be a good idea if you try this and then look at the explanation. So after 2p6, we have over here, we have 3p, so that's 3p2. Skip across. Oh, that's not 3p2. What am I doing? Learn from my mistakes. That's not 3p2. Maybe you do need a label. This is S. This is D, this is P. Yeah, I didn't show a very good example. So after 2p6, we have 3s2, and then skip across this. Here's 3p6. Here's 4s2, and then remember this starts at 3. So 3d1, 2, 3, 4, 5, 3d6. So there's the electron configuration for iron. And it may help. I mean, I don't know whether you want to write all this stuff, whether you feel like you can do it, but it might help to just write the period numbers down there on that side and maybe just remember S, D, and P like that. Let's take a look at one more example. So this example, let's take a look at, let's try sulfur here. Now, why don't you try to write the electron configuration for sulfur and then watch the explanation, see how you do. So I'm going to go ahead and number these so I don't make another embarrassing mistake myself. As I do this, remember this is the S block, this is the D block, this is the P block. So we go, and the other thing is, remember we really moved helium over here, but so, or you don't actually have to do that each time. If you want to put it over there, that's fine. So 1s2 is the first, and that's it for this first period. Then right here we have 2s, so we have 2s2, and then we go across, we get all the way to neon, we still haven't made it to sulfur, so we write down 2p6. Then we have, this is 3s1, 3s2, and then once again, where you really have to be careful is where it is, because we just know it's going to be all the way to the end of these, and then we have 3p1, 2, 3, 3p4. So there's the electron configuration for sulfur. So hopefully these examples have been helpful. Hopefully you've learned from the mistakes that I have made, and you're much more careful and better at this than I am. And if not, come in and get some help. I'll be happy to help you before, after school, at lunch, anytime we can do it. I love to write electron configurations.